Hello everyone and welcome back to Quiet Circuits. Today we are doing a practical build. You will learn how to build a hybrid search pipeline that uses vectors for meaning and keywords for control. By the end, you will have a clear sequence to implement, plus a checklist to evaluate the results. Let us get started. Why we build a hybrid. If you remember, vectors give recall by matching meaning. Keywords give precision by matching exact terms and fields. A hybrid combines both. That reduces dead ends while keeping the exactness your business needs. The rest of this video shows a minimal, repeatable pipeline that you can run in a few hours and improve over time. Overview of the pipeline. Here is the pipeline. Step 1, prepare content and chunk it. Step 2, generate embeddings and index them in a vector database. Step 3, retrieve a broad candidate set with vectors. Step 4, apply keyword filters to narrow the scope. Step 5, re-rank the filtered candidates with a small model or scoring recipe. Step 6, format the answer and surface highlights. We will go through each step with concrete tips. Step 0, pick a use case and collect data. Start with a clear use case. Examples include help center search, policy lookup, or internal code search. Collect the documents you need. PDF guides, knowledge base articles, markdown notes, and code comments are all fine. Keep a single canonical source per topic when possible. Duplicates create noise for retrieval. Step 1. Chunking content. Chunking is the first technical choice. Split documents into pieces that are coherent ideas. A common starting point is 200 to 500 tokens per chunk. Aim for one idea per chunk. Include overlap between chunks so an idea that crosses a boundary still appears in full in at least one chunk. Store chunk metadata like document ID, title, URL, date, and product or team field. Good metadata makes filtering later simple. Step 2. Embedding generation. Next, convert each chunk to an embedding. Use a stable embedding model for consistency. When you embed, save the raw vector and link it to the chunk metadata. Keep a record of the model name and version you used so you can re-embed if you switch models. Batch embeddings to reduce cost and use retries for transient failures. Also log which chunks failed to embed. Step 3. Indexing in a vector database. Load your vectors into a vector database and choose an index appropriate for scale. For small collections, a flat index may be fine. For millions of chunks, choose a graph or quantized index for speed and memory efficiency. Enable metadata fields so you can run structured filters during queries. Make sure the database supports adding new vectors without expensive rebuilds if you update content frequently. A short note on index choice. If you have under 100,000 chunks, a simple flat index can be fine and gives high recall at small scale. If you have millions of chunks, use a graph index like HNSW for high recall with fast lookups. If memory is limited, try a coarse quantization method such as IVF to reduce the search space first, then refine inside the best buckets. Finally, consider your write pattern. For frequent inserts, pick an index that supports incremental updates. If you load once and search many times, you can invest in a heavier build up front for the fastest queries. Step 4. Retrieve with vectors. When a user query arrives, embed the query with the same model and search for the top K candidates. Choose K large enough to capture diverse meanings. For a first pass, try K equal to 50. You will filter and re-rank later, so err on the side of more candidates rather than too few. Now let us walk through a tiny demo in plain language. Imagine the user types best vacuum for a small apartment. We embed that sentence and drop it onto the meaning map. On the map, it lands in a neighborhood near compact, quiet, and easy to store. The vector database returns passages from product reviews, compact vacuum buying guides, and comparison tables. Notice what did not appear. Outdoor leaf blowers, commercial vacuums, and unrelated tool manuals are far away on the map, so they are not returned. This demo shows the power of nearest neighbors. The system surfaces content that matches intent, even when the exact words are different. Visualize the query as a point and retrieval as the 5 nearest dots the database hands back. Those dots are then fed to the model and used as evidence. Step 5. Apply keyword filters. Now apply keyword filters to the candidate set. Require must-have terms when the business needs exact matches, such as product IDs, legal phrases, or version numbers. Use metadata filters for fields like date, language, or product. If you must preserve recall, allow keyword filters to be soft preferences rather than hard exclusions. For example, prefer results with the product name, but do not absolutely require it unless the use case demands it. Step 6. Re-rank the filtered set. Re-ranking is where quality improves quickly. Build a small re-ranker model or use a scoring recipe. The re-ranker should combine a semantic similarity score and keyword signals. Add freshness or trust signals like date or source priority. Normalize each signal to a common scale and sum them with weights. A starting weight mix can be 50% semantic, 30% keyword, and 20% freshness. Tune weights using a small evaluation set of real questions. Step 7. Format, the answer, and surface highlights. Finally, present the top results with short snippets that show why they matched. Highlight the exact sentence or paragraph that corresponds to the query. If you build a generated answer, include citations to the retrieved chunks and, when possible, quote the source text. Users trust systems that show evidence. Evaluation and monitoring. Keep a weekly evaluation set of 20 to 50 questions. For each question, record which chunks you expect to see and what a good answer looks like. After any change, run the set and log 3 metrics. 1. Retrieval coverage. Did retrieval include at least one good chunk? 2. Re-rank accuracy. Is the top result useful? 3. End user satisfaction. Did the user stop after the first answer? Use these signals to spot regressions from stale embeddings, poor chunking, or over-aggressive filters. Deployment tips and cost control. In production, cache frequent queries and pre-warm embeddings for hot documents. Archive very old content out of the active index to reduce costs. Monitor embedding spend and set budgets. If you need extreme throughput, consider approximate nearest neighbor settings that favor speed over absolute recall and tune them carefully. Quick checklist. Here is a copyable checklist. 1. Chunk with 200 to 500 tokens and add overlap. 2. Store product, date, language, author metadata. 3. Embed consistently and log the model version. 4. Index with metadata enabled. 5. Retrieve top 50. 6. Apply keyword filters as required. 7. Re-rank with combined signals. 8. Show highlights and citations. 9. Evaluate weekly. Closing and next steps. If you follow this pipeline, you will get a search experience that balances recall and precision, and that you can improve iteratively. In the next video, we will demo the code for a simple hybrid pipeline and measure how each dial affects the final answers. If you like this guide, tap like and subscribe. Turn on the bell so you do not miss the build video. Thanks for watching and see you next time.